Hello, welcome back. I'm Victor, and this is we're going to be solving a real-world optimization problem using every skill that we have built. Of course, we're going to be expanding. We're going to be factorizing, graphing, and finding the vortex. And this is where everything will come together. Of course. Now, as you can see here, I have a rectangle in the left in the part of the canvas here, and I have the width as x and the length as y equals to 20 minus x, of course. Now I'm gonna draw a fence around this, of course, and so I'm gonna read the problem itself. A farmer has 40 meters of fencing, and so what we're going to do is we need to build a rectangular paddock. What we also need to do is we need to find dimensions for the maximum area. The question is, so what dimension should she use to maximize this enclosed area? What is asking for is actually to find these numbers. So when they multiply together, how do they be like? How do we find the maximum amount of area? So we need to find parameter 40 equals 40, and we need to find the dimensions for this, the length and the width, basically. So x in here, and so what we need to do is we need to set up the equations, of course. So let's just set it out together. I have step-by-steps here, of course, right above here. So let me just draw that out. So what we already have is 2x plus 2y equals 40. 2x plus 2y equals 40. Now, the reason why I put y equals 20 minus x here is because there's a transformation. It is because I'm going to divide all these by 2, left hand side, right hand side by 2. I have x equals y equals 20. And so what I'm going to do is I'm going to now make this in terms of y. I'm going to subtract both sides by x. So instead of having plus x here, I have y only, and 20 minus x. So this is how I came up with y. I want to put it all into only one variable. And so an area of a rectangle is how many? Is going to be a equals the length versus the width, of course. Length and width. I'm not going to write that out. What is the length? The length is 20 minus x, and the width is x. So I'm going to write x 20 minus x, and we're going to expand this. So expanding, this is going to be 20x, because 20 and x, and now this is going to be minus, of course, minus, and then 2 x's together, we have x squared. This is going to be our area. We can rearrange this to be minus x equals 20x, but both forms work as well. So I'm going to use this other form. So I'm going to use the form that starts with minus x squared first, plus 20x. Both forms work, it's fine. Okay, so we have found the quadratic in x, and because the coefficient of x squared is negative, of course, now we're going to tell our story again. Minus x, a is smaller than 0, so there's going to be a sad face, so it has to go downwards. So because a is negative, this opens downward, and it means it has a maximum point. This is the maximum point. The vertex tells the story. We're going to do our first part right here. So we're going to find the vertex. Okay? Let's find the vertex together. So we have this form right here. So we're going to be transforming this into a equals minus x squared plus 20x. We're going to rewrite this into minus x plus, it has to be minus 20x. This is a little bit uncommon here. Why are we changing this from a plus to a minus? Because we have a minus outside of the parentheses right here. So we need to complete the square. Or we can find a shortcut. So for a quadratic, ax squared plus bx plus c, so the coordinate is usually minus b divided by 2a. So because I want to find the vertex, it's usually minus b divided by 2a. So I need to, I'm looking at this and I'm going, okay, where's b and where's a? B is the coefficient of x, a is the coefficient of the x squared. Now I just need to find this, the vertex. Now a is -1, a is -1, this is going to be -1 here, so this is -2, b is 20, b is 20, and so this will equal to -10. X equals 20 divided by 2 times -1, which is going to be -20 divided by -2, which equals to 10. Okay? I'm going to put a negative here because it's not my -10, it's actually a -20 divided by -2, so we get 10. Okay? So we get 10. So we have found the x, that's the vertex position. I'm just going to write here x equals minus b plus 2a, this will be 10. Okay, now we need to go back to the rectangle drawing, and what we need to do is we need to write 10 meters on each side and then 100 in the middle, of course, because we just found x. So x is 10 right here, this is also 10 multiplied by 10, this will give us 100 meters squared. This will be meters. This also be meters as well. Okay. Now, of course, we have done step 1 a little bit. Okay, we don't need to actually draft it out later. We actually do it later. But what we have to do is we have to have this step when we're doing real world problems. Is does my answer make sense in context? Okay. So we have the width equals 10, the length equals 10, the parameter will be how many? The parameter will be 10 plus 10 plus 10 plus 10 equals 40. That's the parameter, yes. Area will be 100 square meters. And what we need to do is the maximum area. So we need to find whether this number is the largest number that we can find. So we need to check. What if x is equals to 5 and y is 15? Right now, of course, if we check this, we have to together we have the same parameter, but the area would be 5 multiplied by, I'm gonna write here, 5 multiplied by 15, this will give us 75. This is less than 100, so this is not the maximum that we can find. What about 15? X is 15 and y is 5. If the width is 15, the length is 5, the area is also still 75. It's just the same, so it's smaller than 100. It is not the maximum. What about if x is 0 and y is 20, something like that, right? Then the area collapses to 0 because what we have is 0 multiplied by any number is equals to 0, and this is of course smaller than 100, but it also means that you have no width or no length, so that's not really a real shape. So even with our comparisons, we have found really that our answer does make sense in context. Now, of course, if we're still in doubt, draw it out. This is like a habit that has been a classic in this channel, of course. Now we need to sketch the parabola minus x squared plus 20x. Now this is going to be a little bit difficult because I originally planned this to actually like map the actual vertex itself, but unfortunately, if we look at here, the part that is actually being allowed for me to map it out, usually it requires me to map out points like 10 and 100, and that is not really very feasible, because I have to go 10 here. 10 here is fine, but like if I go 100 here, that's gonna be like an that's going to be very, very difficult. So of course this what I'm gonna do here is I'm going to help you understand in terms of in other parts. Okay, so what can we still have? We can still what we can still have is we can still have a parabola. So what I can still do for you is that I can still map out this parabola, so it will of course opens downward. Okay, now the roots are at let me see. Now the vertex, of course, this will be 10. Map this point out. This will be 10, 10 and 100. This will be our points. Why? This is our maximum. We found the maximum amount at 10, x equals to 10, and we found the maximum area at 100. Okay, which is our maximum right here. This is at the peak of the curve. Even though my parabola right now, it looks a little bit ugly, but it's at the peak of the curve. Okay, if we were to draw a horizontal line at a equals 75, let's just imagine this part being a equals 75. It wouldn't go over this because 75 is smaller than 100, and it doesn't really cross, so it has to cross over this parabola. Now I want you to look. The area of 75 that we calculated at x equals 5, okay? So x equals 5 with here, at this point, something like this. And x equals, and y equals 15. X equals 15 also, right? Now this shows the intersect of the parabola at x equals 5 and x equals 15. This shows us as a horizontal line that hits the parabola at exactly 2 of these points. So this is x equals 5. This is x equals 15. A little bit difficult, but you can imagine this a little bit like as a rule that we have learned in the past. Again, less is left, right is more. So because 5 is less than 15, it belongs to the lower left, and x is 5, x when it's 15 is belongs to the far right. This is x equals 10, by the way, so it stays in right in the middle. So the graph will confirm everything here that we have, even though it's not perfectly, but usually when you draft out in your notes, this will be this will look like this. Okay, so that will be the end of this part where we find out the maximum area, and we have found a little bit on maximizing area and quadratic modeling. Now let us recap the habits that we built. Of course, let us go here down here, and whenever we have any kind of this form of quadratic, of course, or any kind of number here, right? What we want to do when you look at this, what you want to immediately think is you want to multiply to C, and add to B. This is our game changer for factorizing. After we factorized into a form of A into B, something like this, then we have to immediately have a habit of thinking A equals 0, B equals 0, because if the product is 0, then at least one factor must be 0 for solving that. When we draft out the vertexes, when we draft out parabolas and vertexes, this point in red right here, which is called a vertex, and the vertex tells the story. The vertex tells the story. What is the story of the vertex? When we actually draw a vertical line that goes through the vertex here, we'll find that the points usually are symmetrical to each other. Here, this is 1, this will be -1. This can be something like 2. And this can be something like -2. Okay? And then what we have also is, does my answer make sense in context? These habits do not stop here, by the way. They will carry on to every maths topic you encounter from now on. And of course, we cannot forget the classic, when in doubt, draw it out and check by substituting them back. These will save your scores. They will. Okay? So, thank you for watching. I'll see you in the next videos. Thank you.